I'm Anil Kumar, and with the help of this video, we are going to understand distance time graph with reference to speed. Sketch a graph to show two runners running at the same speed but opposite directions. Think about it. There could be many different scenarios. Try to sketch few which clearly show that two runners are running at the same speed but opposite direction. Let me sketch few for you. Now what I'm going to do here is that I'm going to sketch few graphs. Some of them may be correct, some of them may not be correct. Now you have to identify whether these graphs really represent two runners running at the same speed but opposite direction or not. Okay, so let me represent the runners in this fashion. Let's say one of our runner is running like this, right? So that's one of our runner, and we'll try to sketch the graph for the second runner which is running in the opposite direction. So distance, time, let's say this is distance and this is time in each case. Okay, fine. Now I want to show same speed and opposite direction. Can I draw like this? Will that represent same speed and opposite direction? Or can I draw like this? Will that represent same speed and opposite direction? Or can I draw like this? Same speed and opposite direction. It might be confusing, but I think it's very clear that all these graphs are incorrect. You cannot run back in time, right? So that is one reason that they all are incorrect. So you cannot draw like that. Well, if I don't really show the arrows and just draw the graph, then it really means whenever you look at the graph, you have to see it from left to right. It actually means that the person is running in the same direction because the time goes positive in this direction, right? Is running in the same direction with same speed. In all the cases, the speed could be same, right? Since the slope is same. Just by pointing arrow in the other direction does not mean that it becomes in the opposite direction. So I guess I should draw some correct graphs now. So that was kind of an error which could have been made at times, right? Now let's try to draw graphs which really represents same speed and opposite direction. Okay, let's say now I'm not drawing a 45 degrees, so I'm drawing at an angle, right? So like this. Okay, now this is first runner, and we'll try to draw graphs so that we could represent same speed but opposite direction. Now in each case, again, it is distance and time, right? Okay, so I'm not drawing the arrows, but that is by default. Now if I have to show same speed in opposite direction, can I draw from here a graph like this where the two angles are equal? Will that represent same speed and opposite direction? Think about it. Okay, now let us say the person is slightly away from the first runner, and now this runner has to run with the same speed in opposite direction. Then what kind of graph could be correct? So let us say we'll try to draw two of them. So one I will draw kind of like this, and the other one I will draw, let's say this is the midpoint, right? Now I'm sure this is the right one, so like this. Now you have to reason out which one of these are correct and why. Well, more than one could be correct also. Now the first one, is it correct answer or not? Well, if these two angles are equal, let us say these two angles are theta, they are equal. In that case, their slopes are equal, right? But this is negative, that is positive. Same slope in distance time graph means same speed, and negative and positive means opposite direction. So that is for sure same speed in opposite direction. So this one is definitely the correct option, right? How about this one? Here what we notice is that the point of intersection is right here. Now at this point of intersection, to reach a point which is, let us say, you can see from here, the distance covered by the first runner is much lesser than the distance covered by the other runner. So here it is opposite direction, but speed is different, right? If we say S1 is the speed for the first runner and S2 is the speed for the second runner, then S2 is much higher than S1 because the second runner covers much more distance. In this case, if S1 is speed of the first runner, S2 is the speed of the second runner, then indeed S1 is equals to S2 over the negative direction, right? In this particular case, we have taken a point so that the distance is equal for both. Since both of them take same time to reach a particular distance which is same for them, their speed is same, right? So S1 is equal to S2. Since they meet, that means what? They are meeting because they are running in opposite directions. Otherwise they couldn't meet, right? So therefore it is negative. Even from slope, slope is positive, right? Here the slope is negative. So you can think about like the runner 2 approaching the source and the runner 1 is going away from the source. But they are, let us say, few kilometers away, then they will meet right in the center since their speeds are same. I hope that is absolutely clear and you understand now that we have two scenarios right here which represents the situation that two runners are running at the same speed but in opposite direction, right? Negative distance, I should say displacement in this case, right? Distances are never negative, but when we show it on a graph like this, we say displacement. So it is a position time graph to be very specific. So we are calling it a position time graph where change in position is displacement. So delta P, change in position is displacement. And displacement, if it is in the opposite direction, it is negative, right? So it is kind of approaching. If you are running in opposite directions and if you are running from different sources, then you are running towards, correct? You are approaching, correct? If you are running from the same point as it is in this case, you are running away from each other, so the distance is increasing, which you can see distance between the two increases. So these are two different cases. In one, we are running away, right? This shows running away. Let me write. And here we are approaching. But both represent same speed and opposite direction. I hope that's absolutely clear. Thank you and all the best.